Welcome to Study Loop.
So we can draw a diagram of the system. This would be the direction of the velocity initial. We could say that this would be the height, h. We can say that this is a distance, d. This is the y-axis. This would, of course, be the x-axis. And we have some angle of launch theta. And so we have to essentially find the height of the buoy and the height of the balloon at a certain time. So we can say that the x position of the balloon is going to be equal to v initial cosine theta times t. We can say that the y position of the balloon will be equal to v initial sine of theta times t minus 1/2 gt squared. And we can say that the y position of the buoy is going to be equal to h minus 1/2 gt squared. So we can say that we're going to use the horizontal motion at constant velocity in order to find the elapsed time after the balloon has traveled a distance d to the right. So we can say d equals v initial times cosine of theta times t. We can say t sub d. And so we can say that TD, solve for TD, this is going to equal D over V initial cosine of theta. So at that time, where is the balloon? So we can say that Y of the balloon would then be equal to V, again, V initial sine of theta, TD minus half GTD squared. So we would essentially plug this into this equation for y balloon, and we get v initial sine of theta, and then times d over v initial cosine of theta, and then we're going to say minus 1/2 g multiplied by v initial cosine of theta d quantity squared. And this is going to equal d tangent of theta minus g over 2 times, we can simply say v initial cosine of theta for the denominator, d quantity squared. And so at this point, we have to say, after we find that, where is the buoy vertically at this time? So we can say y of the buoy will equal, again, h minus 1/2 g t sub d squared. This is going to equal d tangent of theta minus, again, g over 2 times d over v initial cosine of theta quantity squared. And as you can see, this is exactly equal to the y position of the balloon, which means that if at a certain time, the same y position, the buoy and balloon will collide. So that's why it is not smart for the buoy to throw the balloon as soon as he jumps off, because then they'll be at the same y position, and they're going to, and essentially they will, the buoy will hit him. The buoy will be hit by the balloon. That is our final answer. That is the end of the solution. Thank you for watching.